The drone is airborne, weapons attached, target observed, and suddenly, silence. No voice, no instructions. The screen just goes cold. What happens next is not science fiction. It's already written into the machine. When communication drops, drones don't panic. They switch to pre-written behavior. Climb, circle, return home. These decisions were made months before the mission even began. The drone doesn't wonder what to do. It already knows. But this is not a movie, y'all. This is real tech, already loaded into the drone's brain. When communication drops, the drone doesn't freeze or panic. It just switches gears, climbs, circles, or heads back home. These moves, they were planned months ago, by engineers sitting far away. The drone doesn't think what now. It simply does what it's told, long before the mission started. Despite scary headlines, drones aren't free-thinking killers. They can track movement, they can predict paths, they can hold sensors steady for hours, but firing a weapon still requires permission. I know the headlines make drones sound like robo-commandos, but honestly, they're more like advanced assistants. They're brilliant at tracking, predicting patterns, holding a camera steady for hours, but firing a missile, that's still a human call. Think of AI like cruise control. It helps, but it doesn't choose the destination. At least, not yet. AI doesn't understand good or bad. It understands patterns. This moves like a truck. This path looks familiar. This behavior matches earlier data. That's powerful. But it's also why camouflage, decoys, and mistakes still exist. This moves like a truck. This path looks familiar. This behavior matches last month's data. That's why decoys and camouflage still work. Humans stay involved not because AI is weak, but because reality is messy. The instant a missile leaves the drone, physics punches back. The aircraft becomes lighter. Balance shifts. Airflow changes. So the drone compensates before the launch even happens. It's like throwing away a heavy bag mid-run without losing balance. That prediction is what keeps the drone alive. The second a missile launches, the drone is suddenly lighter. Balance shifts. The air flows differently. The drone predicts all this before firing, so it doesn't lose control. Like throwing away a heavy bag mid-run but never missing a step. Here's the math that keeps generals awake. One interceptor missile can cost millions. One small drone can cost less than a scooter. Air defenses were built for jets, not swarms. Stopping one drone is easy. Stopping 50 is chaos. Numbers beat power. But a small drone, that's cheaper than a scooter. Air defenses were built for jets, not for dozens of buzzing drones. Stopping one is easy. Stopping 50, that's chaos. Numbers can beat power. The future won't be pilot versus pilot. It will be sensor versus sensor, algorithm versus algorithm, learning speed versus learning speed. The winner won't be faster. The winner will be smarter sooner. The winner isn't the fastest. It's whoever can learn the quickest. End of the day, drones changed war not because they fly, but because the pilot can be sitting anywhere. Distance, risk, decisions, all shifted. Drones didn't change warfare because they fly. They changed it because humans don't have to be there anymore. Distance disappeared. Risk moved away from pilots. Decisions sped up. And the final question isn't about technology. It's about how much control humans are willing to give up. How much control do we want to hand over to the machine?